Hey all, welcome back to the Postmortem series for Color Jumper. This episode I wanted to talk about how the beams were made inside of Color Jumper. So one of the more frequently asked questions that I've gotten are how the beams are coded inside of Color Jumper, because they are dynamically generated. They aren't an animation or anything like that. And while this isn't hard, it does go into the process of creating dynamic meshes within Unity, so it's a little bit scary if you're newer to coding. What I want to do in this episode is go into detail on what dynamic meshes are and how they are made within Unity, and then go into more detail on how I implemented that within Color Jumper itself. After I explain how dynamic meshes work, I'll step through the code in Unity and kind of explain step by step how things are generated in there. And now I should mention this isn't really the only way to do this effect. I think using a vertex shader would probably work just as well, and it might be a little bit more performant, but for newer developers, doing the dynamic mesh is probably a little bit more easy. So I'm going to move over to the table and describe how it works. Okay, so I'm going to give a simple explanation of dynamic meshes, and keep in mind that this is a simple explanation, but it should do the job for right now. So a mesh is made up of triangles. So any mesh you see in a video game is made up of triangles at various angles and so forth. So that is how things are built inside of a game. And because of that, each triangle has 3 points of reference. And what we do when we generate a dynamic mesh is we create an array of vertices. So it's an array of vector 3 verts. And then we have an array of integers for the triangles. And those triangles are actually reference points to the vertices. So you would be like 0, 1, 2, which would be the first, second, and third position inside the vertices, because arrays start at 0. So what we do when we're creating a dynamic mesh is we set up the vertices and then we assign the triangles to those vertices. And I should also point out that the triangle array here must be a multiple of 3, because each triangle consists of 3 points in space. So if it's not a multiple of 3, you're going to have problems in the future. So let's take a minute to plot points and make a square. Let's say that we have 4 points in space here. We have 0, 0, 1, 0, 0, 1, and I realize I'm doing this upside down and I apologize, but that's okay. So if we wanted to make this square, we can't just go all the way around like this, because that would be a square and not a triangle. So what we need to do is we need to create a triangle like this and a triangle like this. So our vector 3 of vertices here would be these 4 points. Now if we wanted to create a triangle out of that, let's for the sake of argument just say that this is position 0, this is position 1, this is position 2 inside the array, and this is position 3 inside the array. So this vertices array up here has 4 points in it. So when we're creating a triangle, we need to actually build the triangles out of this. So it would be basically 0, 2, 1 for this, and then it would be 2, 3, 1 for this. That's basically all we have to do to create this. And then there's a bunch of computations that happens at the bottom here for actually meshing everything together and turning it into an object that Unity can properly render. But let's move over to the code and look at that, and hopefully we can get a full explanation of how it all works. Okay, so here we are in a fresh new project in Unity. I am going to have the code available for this in a Pastebin link down below, so go check that out if you want. So I have the code right here. I'm just going to do a select all and copy, and I'm going to create a new C# script called Beam Controller. And this does have to be named Beam Controller unless you want to change the public class name as well. So I'm going to open this up and just copy everything and replace it with what was in that text file or that paste bin. And then we hit save, and we will go into more detail on this in a moment, but I'll show you the final product first. So we can just create an empty game object here and drop the beam controller in. You'll see that it will create a mesh filter and a mesh renderer automatically. And then what we can do is when we run the project, we will get, in my case, a wireframe because I have this set to wireframe, but if you have it shaded, there we go. And inside the wireframe here, you can see it's the same concept as the boxes. We're creating points here, and then we're generating boxes from it. But what we can do now is we can animate those when we mess with these controls. We can raise the amplitude and the frequency, and you can see now that we can increase the detail, and you can see the mesh up here, and also the object, the final render down here, has a little wavy feel to it. So this is basically what we're creating. We're creating boxes, but we're also modifying these points in space every frame, so it looks like it's moving dynamically. Once you get this, you can mess around with it a little bit more and mess with it. And then we have a noise filter here, which gives it that jiggly effect, which makes it feel a lot more energized. Okay, so I'm gonna stop this and we can go into the code and kind of go line by line here. So the first required components are here, so we automatically fill in the mesh filter and the mesh renderer here. So these are required components to make this work. So I'm just forcing Unity to include them when we load the script. This is a lot of variables that we're instantiating right away. We're just setting the width and the length, linking the mesh, adding the mesh detail, which is how many squares we're including in this, and then wave amplitude, frequency, speed, noise. All of these things are variables that we're going to be inputting into the formulas down here when we get there. So we're basically assigning beam mesh to the mesh filter in the start function here because we're going to be using this every frame to assign the mesh. And down in the update function here, this is where we actually get into it. So right here, you can see that we're assigning an array for the beam vertices, and we are creating that array with the length of the detail of the mesh times 2 plus 2. And what I mean by that is the detail of the mesh is how many blocks there are here. So we have times 2 because there are 2 points per block here, and plus 2 because at the end we need to cap this off. So if the detail is 5 right now, we're going to have 5 blocks, so it'll make 1, 2, 3, 4, 5 sets, and then we'll add one more at the end. And then we're doing the same thing for the beam triangles, and since each block here requires 6 points, we're basically taking the mesh detail and multiplying it by 6 because there are 2 triangles per block. So what we're going to do now is we're going to start a loop for depositing these vertices in space. You'll notice that I'm iterating I by 2 in this case because it's going to be a lot easier to push the X value on top of each other here. Instead of iterating by 1 by going top, bottom, top, bottom, top, bottom, we just go by 2 because then we can just paste both of them in at the same time. So the first thing we do is we set that X position. Now I don't want to go into all the math here, I just want to explain this conceptually, so if you wanted to look more into the math or mess around with this, you're more than welcome to. After this we set the Y position, and this is a little bit more complicated because this is where all of the variables that we set up earlier come into play. I have a simplified version of this right here for the formula, and basically this takes into position the time, the speed of the waves, the frequency, and the amplitude. And the X position here is very important because what we're doing is we are setting this sine wave to move through time. We don't want all of these values to be exactly the same because then the beam would just oscillate up and down as one whole. If we space them out by the X position, that gives us a little bit more leeway when it comes to creating a wave. So down here we are actually assigning these beam vertices with vector 3s. Notice again, since we're incrementing I by 2, we're doing I and I plus 1 for the top and the bottom. You can see the beam width here is what we use to push it up and down. And down here we create all of the triangles. And now this looks kind of confusing initially, but if you think about it, what we're doing is we have a box here. When I is 0, I is 1, I is 2, and I is 3, we are basically creating a triangle going from 0 to 1, and then going from 2, 3, 1. Now it's important, and I mark this here, that it's important to go clockwise with these, because if you go counterclockwise, the faces of those triangles would be pointed away from the camera and you wouldn't see anything. So always go clockwise when you're doing this. And then that's really it for the loop here. After the loop is finished, we create a mesh and we assign the vertices and triangles to it, and we recalculate some of the bounds and normals, which is a little bit more advanced. I'm not going to go into details with that, but it's basically just preparing this mesh to be rendered, and then finally we assign that mesh to the beam mesh variable, and then it is ready for Unity to render it. And then at the start of the next frame, we go to the top of the update again and we do it all again. And that is basically all of it. So again, I'm going to have this code in a paste bin in the video description, so please, I highly recommend you go check that out and explore this code yourself. It is very easy to set up. Again, you just got to dump it into an empty game object and hit play. Everything should work right out of the gate. And yeah, that is basically it. Look at it go. So if you have any questions about this process, please don't hesitate to get in touch with me. I would be more than happy to explain something that might be confusing to you. I do plan on doing more postmortems in the future. I think the next one on the list is talking about managing your Steam keys and trying not to get them scammed by either shady people or websites that are out there, because it happens a lot, and I encountered a lot of that even as a small developer. So until next time, thank you so much for watching this video. If you'd enjoyed it, click that like button and consider subscribing if you wanted to see more information like this and more music in the future. I'll see you next time. Take care.